Okay, so I wanted to see number one, determine mu x bar and sigma x bar from the given parameters of the population and sample size. So whenever the question mu x bar and standard deviation x bar, you already know that standard deviation x bar is called standard error. This is standard error, and that is the standard deviation of central limit theorem. And mu x bar is the mean of central limit theorem. So we talked about this for a long time. So they just want to know if you remember your central limit theorem. Remember that central limit theorem says that it does not matter if the original data, even if it's skewed right, normally distributed, or skewed left, doesn't matter the distribution of the original data, the density curve formed by means x bars must be normally distributed. The density curves formed by the means must be normally distributed with the mean of central limit theorem. This one is central limit theorem. It's also called mean distribution. It's also called sampling distribution, no matter what they call it. Mean distribution, sampling distribution, central limit theorem, they are the same. You just have to know they are talking about the same thing. And by the way, whenever you start, you see this, mu x bar is talking about central limit theorem. All right, so the mean of this mean distribution is mu x bar. That's what we're talking about, mu x bar. And again, and it is equal to the mean of the original data. By the way, let me ask, I hope you received this practice test. I actually looked at it, I saw it as the test. But anyway, just when I print it again, it's not going to be exactly the numbers. And then the important thing is if you understand the scales, the numbers will change though. But if you understand the scales, that's just enough. Okay. So the mean of central limit theorem is 48. The standard deviation of central limit theorem, which is called the standard error, is equal to 23. Actually, the standard deviation of the original data divided by square root of sample size. Sample size is 37. That's all they want you to emphasize here. If you're to round your answer to 3 decimal places, which means you have to simplify. So this is 48 mu x bar, and I'm going to evaluate the standard deviation of the original data is 23 divided by square root of 37. So I have to pull my calculator up and evaluate that. So let me find my calculator somewhere. And then I will pull it up. Hopefully it is somewhere around. All right, so you're here. Okay, can you see this calculator, somebody? Are you seeing it?
Yes.
Okay, great. All right, so all I want to do now is calculate the standard error. Remember, standard error is the standard deviation of central limit theorem. So I'm going to put 23 divided by square root of sample size, and the square root of this square root of sample size. So I am going to put that in, which is 37. All right, so looking for the square roots of sample size, 37. So when I hit enter, I get that the standard error is 3.78. Let me see, who is that? Please mute yourself. You gotta mute yourself, please. So I'm going to mute you, but really, you need to mute yourself. I want to know who's there. All right, so mute yourself. Cole Spark, are you the one? Please mute yourself. Okay. All right, so that's all. That's all what question one is talking about. That's all what question one is talking about. All right, so let's go to question two. And when you see your test, it will contain a z-chart, and t-chart. That is because if you might want to read the chart, but you don't have to read the chart. Don't have to read the chart, but see, I have to put it in there in case anybody likes to read the chart. Okay, question number two. Let's read this. Let's read this question. This question in this test. Let's read it. All right. So this question says, a sample, remember, you have this question. I sent it to you, so you have it already. A simple random sample of size n is drawn from a population that is normally distributed. The sample mean of this, the sample mean for this data is x bar, round, and then the found to be this 115. That's the sample mean. And the sample standard deviation S, that tells you is a t. This question is about t because we don't know, even though the sample size may be high. Okay, so sample standard deviation is S. So we have our sample mean X bar is 115. And sample standard deviation is 10. So these are what we are given for now. Now, S says construct an 80% confidence interval about the mean if the sample size is 25. So suppose the sample size is 25, I am told to find the confidence interval is 80.8. Okay. And then I think I have everything to do this confidence interval. I know the formula, so you don't really have to use the formula, but if you want to use the formula, or for any question, any reason, somebody wrote the formula for you and wants you to use it, you can just write the formula. And by the way, I'll write the formula on the board that day. I will write the formula. And this formula says the mean of the population is equal to the point estimate, which is the mean of the sample, plus or minus the critical value T2-tailed multiplied by standard error for T. So the standard deviation, small sample over square root of sample size. So this is the formula for confidence interval for the mean, where the sample is small and the population standard deviation is unknown. Okay, and this is the most important thing because really we are not talking about where the population standard deviation is known. Because really, what am I estimating? If the population standard deviation is known, then the mean should be known. So the point that we have to be thinking about, that's nowhere you should know the population mean and population standard deviation. Because suppose you're talking about the average mileage driven by all truckers in the whole world. Average mileage driven by all truckers in the whole world. Trust me, there's no way you can find truckers in the whole world. You can only find probably the ones in South Carolina. So you can choose a sample from South Carolina, which is You now make a decision with that sample, and then when you finish, you generalize into the public. And when you are generalizing, you say you are doing inference. You're doing inference. Okay. By the way, we don't have to use this formula. I show people this formula, and really, you're going to have 10 questions in the test. And by the way, if you have 10 questions that are like this number 2 has 1, 2, 3, 4. So there are 4 sections of number 2. So say you have 10 questions, so each of them has 4 sections. You actually have 10 times 4. That's 40. So you don't really have time to waste. So that's what I'm talking about, the formula. But anyway, in case somebody wants you to populate the formula, you need to show them you know how to populate this formula, because you are given almost everything. You're given the statistics. The point estimate, which is sample mean, is 115, plus or minus. The critical value, you are given the confidence interval. And if you're given the confidence interval, you know alpha. So alpha is 20%. But for confidence interval, you have to divide alpha by 2. So if you divide 0.2 by 2, you have 0.1. And so you are now going to find inverse t, which we call critical value. Inverse t for 0.1. Remember, you are using t distribution because you don't know the sample, you don't know the population standard deviation. So this is a t confidence interval. That's why we are doing a t confidence interval. So you're going to do inverse t, not inverse norm. So the critical value is critical value for t. This one right here. And then you populate the standard error. You already know that the standard deviation is 10 divided by square root of sample size, square root of 25. You already populated the formula. You don't have to use this formula. Now you go to your calculator. So I'm going to go to my calculator. And by the way, we are allowed to use our calculator. So what are we saving it for? So I'm allowed to use my calculator. So I pull it up. I pulled it up before. Let me find it. Find my calculator somewhere. It should be here. Or did I? All right, I'll get it again. I'll get it again. Okay, so I am going to clear. Well, I want to see if, do you see this calculator that I pulled up? I want to make sure that you can see it. Can you see the calculator that I just pulled up?
No, I can't.
You cannot. All right, because I think this was not the one that I shared. So I can stop sharing my screen and make sure that I share the calculator again. So I will go back to and then I will stop sharing my screen so I can share my calculator. All right, so let me share my calculator this time. All right. Okay, so I'm going to share my screen again in such a way that I'm going to share my calculator. That way, everybody will see where we. I just want to remind you that you can use your calculator for a lot of things, for a whole lot of things. So I'm sharing my calculator right now. Let me see what else I need to share. I want to, yeah, I'm sharing the worksheet. I'll be needing this PowerPoint too. That's it. Okay, so I'm going to share this time. All right, so I hope you can now see this calculator, right? Hello, you can see it?
Yes. Yeah, we can see
Okay,
the
great.
calculator.
All right, okay, now we want to do confidence interval with our calculator. Remember how to do it. Go to start and arrow to to test, and you are doing T confidence interval. So I'm going to arrow down to T interval. So that's T interval here, number 8. So I select that. And my calculator is asking me, do you have raw data? And I'll say, no, I don't. I don't have raw data. So I have stats. I'll select stats. And it's now asking me, what is the point estimate? That's the sample mean. The point estimate given to me is 115. So 115. And I'll hit enter. The sample standard deviation is 10. The sample size is 25 from the data given to me. The confidence level they gave me is 80%, 0.8. Uh-oh, where is it? Okay, I need to go back. Okay, go to start, arrow to test, and number 8, T interval. So confidence level is 0.8. All right, now I'm going to calculate. So I am going to calculate, and it gives me the confidence interval. Says that the confidence interval is, the lower bound is 12.364 and the upper bound is 17.636. Okay, so let me see if there's another question there. So let me see if there's another question in that. So actually you see that the A part of the question is what I just answered. And so we answered the A part of this question, 80% confidence interval with sample size of, okay, so I'm going to just document the confidence interval and leave it there for now. So my answer to A is 12.364 to 17.636. Okay, so I am going to clean some stuff here, some stuff out. All right, so for this first question, the confidence interval is from upper bound and lower bound. So lower bound is 12.64 and the upper bound is 17.636. 636. All right, so this just reminds us how to do confidence interval. And the point estimate is X bar, and X bar is already given to us. The point estimate is, okay. So let me go back and see that question again. Okay, let me go back and see. I think something is the data here. I want to make sure I enter the right data. I'm going to enter it again because it seems to me that the data I entered is not the same as what I have. Okay, let me make sure there's no mistake. Okay, see, X bar is 15. It's supposed to be 115. Sorry about that. X bar is 115. I put 15 there, sorry. 115. Makes more sense now. And standard deviation is 10. Standard deviation is 10. And sample size is 25. All right. Confidence level is 0.8. Let me calculate again, because really that makes more sense, because the mean should be between lower bound and upper bound. So the mean should be between the upper bound and lower bound, but from the first calculation, it is not. So that's when I noticed that something is wrong with the numbers are entered in there. I hope we can all check ourselves Yeah, so, okay. So I found the boundary again. The correct boundary is right here, 112.36 and 117.64. So that is the boundary here. We are trying to do something, make something out of this. All right, so the lower bound is 112.36. All right, so 112.36 to 117.64. When you finish the confidence interval, you want to make sure that the mean is between them. The mean has to be, the X bar has to be between the confidence interval, because actually the mean is the point estimate. It has to be the midpoint. If for any reason, that's what I looked at, if for any reason the mean is not between your confidence interval, then there is a mistake somewhere. Somebody screwed up. So you have to fix it. Okay, so we did number two, section A. Well, it says construct another one, another 80% confidence interval about mean if the sample size decreased to 13. In other words, we want to know what happens when the sample size decreases. So it is the same data, except that the sample size decreased to 13. So I'm going to put my calculator up again. That's not a lot to change. I just have to go to start, to test, T confidence interval. The only thing that changed is sample size. So I will just switch 25 to 13. And then I will recalculate the confidence interval with 80%, the same 80%. So really, what are we looking for? We are looking for what actually happens when the sample size is smaller. What happens to maybe the margin of error? Let's see what happens. Okay, so let's calculate. So when the sample size is smaller, the confidence interval is from 111.24. So for this one, I have 111.24 to 118.74. 118.74. I want us to know that the margin of error, we can be told to calculate the margin of error. Margin of error is upper bound minus lower bound divided by 2. So let me find the margin of error here. I'll get my calculator quickly. What is the margin of error in the first one and the second one? When the sample size was 25, the margin of error is what I'm looking for now. 117.64. 0.64, and I am subtracting the upper bound, the lower bound from this, 112.36, and I get an answer. Then I divide the answer by 2, and I get the margin of error. So the margin of error is 2.64 here. So I'm going to find the margin of error when the sample size decreases, and then I'm going to make a decision. What happens when everything is left intact except the sample the sample size decreasing? How does the decrease in sample size affect the confidence interval or the margin of error? Okay, so let's do that. The upper bound in sample size of 13 is 118.78 minus 111 0.24. When I hit enter, I get the margin of error divided by 2. This is the total margin of error, but I need to divide it by 2. Okay, so the margin of error is higher when the sample size increases, decreases, sorry. When the sample size decreases, the margin of error increases. So when the sample size is smaller, the chances of making a type 1 error increases. In other words, the rejection region is going to decrease. The rejection region is going to decrease. You might accept a wrong null hypothesis when it's actually false. You can accept a hypothesis when it's actually wrong. Type 2 error. That's type 2 error. Accepting the null hypothesis when it's actually wrong is an error. So the decrease in sample size, you're not even supposed to say it that way. You just have to say that there is an increase in margin of error. But if you actually say it that way, that's good. So I'm not going to do any more in this number 2. I just want to let you know that you can have 10 questions and they have sub-questions. So this is just a review of, we just reviewed central limit theorem. Now we reviewed confidence interval. So the next thing we're going to review is hypothesis testing. By the way, any question before I continue? Any question? So we reviewed confidence interval. I wanted to make sure you know how to use your calculator to do it. Even if you're told to use formula, you just have to populate the formula and go to your calculator and get the accurate answer. Any question? Okay, so the next question is going to be hypothesis testing. Let's test a hypothesis, maybe for one tail test, right or left, and one two-tail test. Remember that by the way, I think we can do a hypothesis test with the real world data. So anyway, let's do one and then we do another one with the real world data. Okay, so let me scroll down and get a hypothesis test, because those 3 things: hypothesis testing, confidence interval, and central limit theorem are the things in the test. Chapters 9, 10, and 11. Chapters 9, 10, and 11 are what is in the test. So we talked about central limit theorem. We talked about confidence interval. Not that we're going to say everything in this gathering, though, but we're going to touch at least each one of them. All right. So I found a confidence interval right here. Hypothesis testing here. Okay, so let's look at this question. If you look at question number 3, it's a hypothesis testing for me. And then let's read the question. This is a right tail test. How do I know that? Because the alternative hypothesis given to me says less than. In other words, I cannot use, see, there are actually 3 ways of testing a hypothesis. Number 1 is by the traditional method or the test statistic method. By the way, let me write test statistics here. This formula you must know. We'll try and write it on the board on the test day. So is the random variable x bar minus mean divided by standard error. This is the t. Just like we can calculate the z-score. This is the t-score for central limit theorem. So when you're doing the t hypothesis testing, and you're told to calculate the test statistics, it is actually the t-score for central limit theorem. And we already talked about it. We knew that from chapter 9, central limit theorem. But it doesn't hurt to talk about it again. Okay, so let's do the hypothesis testing in number 3. And this question in number 3 is already we know they're given. That's an easy question. That's good. All right, so I'm going to document what I'm given in this question. Oh, the givens. It's always good to write down what you're given. That way you will just pick it up anytime you need them. So right here, I want to write all the givens here. Right, all the givens. And all the givens here. So in this question, I am told that the status quo is 50. The mean we're talking about. Well, that's what we're going to debate. And if we are if this is the mean I am debating, and I'm told it's a right-tailed test, right-tailed. It is right-tailed. I already know that. Oh, actually, it's not right-tailed. It's left-tailed because it says mu is less than. So I'm going to take this. I'm take this one. Sorry, it's left-tailed because it's less than. It said mu is less than, so it's left-tailed. 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 Okay, so left-tailed, and I'm given that sample size is 22. 22 is less than 30. So this is a candidate for t-test. It's obtained from a population that is known to be normally distributed. Okay. Actually, they also told me say t-distribution. That was an easy question though. And anyway, so X bar is 47 from a sample. Somebody picked up a sample to test another person's hypothesis. The claim, the status quo is 50, but somebody does not agree, so he got a sample, and a sample size of 22. That's a small sample. And then found that the mean of the sample is 47.4, and also found that the standard deviation of that sample is 11.9. Okay, and the first thing is to calculate the test statistic. Oh, but my calculator will calculate it for me. So really don't. Okay, and if my calculator will calculate it for me, I can just wait for it. But the next thing I want to calculate, because my calculator will not calculate it for me, the critical value. No, my calculator will not calculate the critical value for me. So I have to source the alpha wherever it is. So alpha is 0.1, 10%. And it's a one-tail test, one-tail left. Okay, so I am going to draw a normal curve showing that it's a one-tail left test, and area to the left is 10%.1, and I'm looking for T alpha, which means I'm not going to divide alpha by 2. I'm not going to divide alpha by 2 because it's a left tail test. So, and I already know to find T alpha, I do inverse T. You don't forget this. Inverse T, area to the left in decimal is 0.1, and the degree of freedom is the sample size minus 1. The degree of freedom is 21. Remember, I have to be careful because the question can actually give you degree of freedom. If the question gives you degree of freedom, then you use it like that. You don't have to be. You don't have to subtract it. Subtract 1 from it. Okay, now let's calculate. Let's use my calculator and calculate the inverse T. So let's go and calculate the inverse T at 10% with 21 degrees of freedom. So to get inverse T, I go to distribution. Inverse T is number 4. So I just want to make sure we touch every section. So you know, by the way, the most important thing is that the test contains chapter 9, central limit theorem, chapter 10, confidence interval, chapter 11, hypothesis testing. Okay, so area to the left is 0.1, 10%, and it's 1/3, so I don't have to divide by 2. The degree of freedom in this question is 21 because sample size is 22. So I'm going to calculate the critical value. When I calculate the critical value, now I'm going to use it to make a decision. So the critical value is negative 1.32, negative 1.32. Let me actually write it with another color. So negative 1.32. So I just want to remind you that this line, negative 1.32, is the boundary line between acceptance region and rejection region. The rejection region is the shaded region. The acceptance region is the clear region. That is the boundary line. So now, when I get the test statistics from A, I will compare it with my bell-shaped distribution that I drew. If my T falls into the acceptance region, I will accept the null. Remember, you do not have any business accepting the alternative. Okay, so let's go ahead and do it. Put everything in our calculator. So we now know almost all we need, and we calculated the one that calculator will not give us. Calculator will not give you the critical value. You have to find it. So now I will go to start, and I will do a t-test. T-test is number 2. And what am I given? I'm given statistic. And I will arrow down what is the mean in question. What are we debating? What is the status quo? 50. The status quo is 50. The sample size the sample mean is 47.4. 47.4. The sample standard deviation given to us is 11.9. And the sample size is 22 in this question. What kind of test am I doing? My calculator actually knows that there are 3 kinds of tests, but I'm doing a left tail test, so I select left tail test. And I really like to draw, so I'm going to draw. Whenever I'm drawing, I like the shading. If a greater portion of the normal curve is shaded, it's an indication that p-value is greater than alpha. Watch it. P-value is 15.86. 15.86 is greater than 10%. Therefore, p-value actually has accepted the null hypothesis. Well, let's look at the test statistic. You see, I told you that our calculator does the test statistics for us. So it is negative 1.0248. Let's compare it with the boundary, with the critical value. Does this number fall into the acceptance region or into the rejection region? It falls into the acceptance region. That's 1 point something. Negative 1.02, negative 1.02. So, using the test statistics, falls into the acceptance region, so I will accept the null. using the p-value. P-value is greater than alpha. I will accept the null also. And these are the only two I can use because this question is a one-tail test. I'm not allowed to use confidence interval. It is a one-tail test. But these two are enough. If p-value accepts the null, and the test statistics accepts the null, then we do not have any business with the alternative because the status quo is still 50 and is still working. So if you were hired by by somebody to go and do this test and come and report to them, then you tell them the status quo is still working. There is no need for change. Because really, you don't change what is working. Any question? This is a one-tail test. I think we need to do a two-tail test. Let's do a two-tail test. That's going to help us, even though we have done it before. If it's a two-tail test, we can test with confidence interval. All right, let me check and see where I can find a quick two-tail test right now. I'm going to look for a quick two-tail test. When I get this question, I want to see if, what else? All this. I don't need any arguments. I have a class to teach. What kind of this? All right, I'm going to exit out of this one. All right, I will exit and go back to my, okay, I'm go back to what I'm doing. Okay, looking for that worksheet that we had. Okay. Okay, still recover this. It's gonna be blocking my way. All right, so I'm going to check for a two-tail test in this worksheet. There is a two-tail test here. Somewhere I can find it. And by the way, I hope you know, I hope when you see this question, you better know that this is central limit theorem. I hope you know that this question is a central limit theorem question because it's asking you to find the area under the central limit theorem, under the normal distribution that is that is populated by X bars. So the random variable is X bar, which means you are going to calculate the area under the central limit theorem. The only thing that is going to change, and make sure, I'll write the argument again. The argument is normal CDF, the lower bound, the upper bound, the mean of central limit theorem, and the standard error of central limit theorem. You can't miss it anyway. The standard error, and I hope you remember that standard error will be, even if it is for t, you write sx bar, and it's going to be the same as s divided by square root of sample size. You can't miss this question. Can't miss it. We did it in class. Okay, so you could be given if under the central limit theorem or area under the ordinary normal curve. Well, if this question is about area under the ordinary normal curve, then it will be find the probability that x is greater than 77. S without any bar on it. So if this question is area under the ordinary normal curve, then there will be no bar on your x. That's all the difference. They will not tell you that this is central limit theorem question, but they will use that random variable x bar. That tells you it is x bar. Okay. So you can answer this question number 4. Okay, let me determine the point estimate. The point estimate, whenever you're given, let's look at this. I hope we still have time. All right, we do have time. Okay, determine the point estimate of the population mean and margin of error. This is an easy question. Let me make sure that nobody fails this question. This question is in the test, and it may not just come like this. You can just change when I print again, because actually I sent you the test from last semester. But it's not. I'm not going to send you their test. I'll send you your own test. So when I click and print again, your own test will not show exactly the same numbers. But if you know what you know, the skill you know, you should know it even if the numbers changes. So this is the lower bound of this is your lower bound in a calculation of you calculated confidence interval, lower bound, and this is upper bound. Remember that the center is the point estimate, X bar. And the question says, determine the point estimate. Remember that the point estimate means X bar. You can't forget that. Last year, somebody told me I don't know what is point estimate and really failed this question because he never paid attention and he never studied the packet I gave him. See, this packet, I always give it 2 days to test. But if you study it, you will never fail the test I'll give you. Because I just couldn't, sometimes I just regurgitate the same practice test. I just pull up the practices and give it to you at the test. So the person who was saying this never actually looked at the practice test. I don't have to give you to you 1 month to the test. I'll give it to you maybe 2 days to the test, because if you have been studying, it's just a question of remembering what we did in class. Anyway, by the way, if I'm told to find the X bar, which is the point estimate, all I'm going to do is upper bound plus lower bound divided by 2. So let's do that. 29 plus 21 is going to give me 50. 29 plus 21 will give me 50. 50 divided by 2 is going to give me 25. Is it 25? Yeah, it's 25. So it's going to be 25. Therefore, the point estimate is 25. So we found the point estimate. What else did they tell us to find? They also told us to find the margin of error. The margin of error, remember, the margin of error is always, ME is always upper bound minus X bar, or point estimate. So what is upper bound minus point estimate? 29 minus 25 is 4. This is the margin of error, the distance between upper bound and, likewise, X bar minus lower bound is 4 too. So that is the margin of error. All right, so if you want to actually state the hypothesis here, you will say under the confidence interval given to you, the mean of the population is equal to X bar, which is 25, plus or minus margin of error. Under the confidence interval given to you, you will say, I am 90% confident if it is, I am 90% confident that the mean of the population is 25 plus or minus 4. Or you can say it lies between 21 and 29. I don't know. I don't know what the mean of the population is, but I know that it lies somewhere from the lower bound to the upper bound. Okay. Number 6 is area under the standard normal curve. I hope nobody is going to mistake number 6 to be central limit theorem. Number 6 is no central limit theorem. It is not central limit theorem, number 6. It's not central limit theorem. Okay. So you want to find the area to the right. So I'm going to draw it for you, but I'm not actually trying to do it. I'm just going to draw that diagram for you. So I'm told to find area to the right of this. So I draw a normal curve. For every question in normal curve, you draw a normal curve. So the Z 1.31, actually the normal curve has mean equal to 0. So when I have 1.31, it is a number. It is 1.31 standard deviations. 1.31 standard deviations. So I'm finding area to the right. And this means area from 1.31 to positive infinity. And I want you to remember that positive infinity is 1e to the power 99. Don't forget. Okay, so what do I do right now? I will know. I already know that the argument is normal CDF. Normal CDF. So I will go to my calculator, normal CDF. Lower bound is a number here, 1.31. Upper bound, positive infinity. The mean of a standard normal is 0. The standard deviation is 1. Because this question is area under the standard normal curve. It is not central limit theorem. This question is not central limit theorem. Therefore, you can use the ordinary normal curve. I hope this question is right. I mean, clear to everyone. Any question? We have one more to do. I'm looking for a two-tailed hypothesis testing. That's all we need to do. Any question? Hello, I'm going to ask you if you have any question. Let me actually pull up the, let me pull up. Let's see if I have anybody in the chat. Any question? All right, I'm here. My microphone isn't working. Okay, I see. I'm going to check those who are here. Okay. All right, so let me we have done a lot of, by the way, we have done a lot of questions two-tailed. All right. Okay. We're looking for two-tailed test. Oh, no, it's not a two-tailed test. So I
think number 11 is a two-tailed test.
Oh, let me check that. Thank you. So I'm looking for a two-tailed test. Wow, great. Number 11 is a two-tailed test. Thank you. Okay, well, let's do that. I just want to remind us that anytime I'm giving a two-tailed test, I can use confidence interval to do that test. I don't have to be told. I can just decide to test the claim.
I'm not dating a 15-year-old.
Say it again.
I didn't hit on a 15-year-old. Steven, shut up.
You're right. She was 14.
that was good.
What?
Let's see. Is that? Let's see. I don't know who that intruder is, but anyway, I can continue. But please mute yourself. Remember that we are in class. Remember that your cell phone belongs to you 24/7. We just have a few more minutes for the class to be over. Okay, so I'm going to share again. We were interrupted, so that's why I stopped. But anyway, let me share again. So I'm going to share and get my calculator. Get this worksheet right here. Get my calculator. What else do I need? I think that's it for now. So I'm going to share again. Okay, so the question, we are going to do number 11. We were going to do number 11. and we were rudely interrupted. Okay, so we are told to test the claim that the status quo is 100, and the alternative is not equality. Okay, so what we are doing right now is making sure that we remind ourselves how to test hypothesis with confidence interval. But when do I test a hypothesis with confidence interval? Only when I am doing a two-tailed test. Only when I'm doing a two-tailed test. So the first thing I want to do is document all the givens. So I'm just going to go here and document all I'm given. I'm given that the mean I'm contesting is 100. Okay, and I'm given that it is a two-tailed test already. Two-tailed. And I am given that the sample size is 15, candidate for t-test. And I am given that the sample standard deviation is 9.5, another candidate for t-test. And I'm also given that the sample mean is 108 or 105.8. And I think that's all I'm given. That alpha, I'm given that alpha is 0.01%. Okay, the things we must know are, the first thing is a two-tailed test, so I'll divide alpha by 2 to find the critical value.
We can't see it. All we can see is a zoomed in calculator.
Okay, so you cannot see what I'm writing now?
No, ma'am.
Oh, I'm sorry. Okay. You know what? I'm going to stop share. And thank you so much for letting me know that. Okay, so I am going to share this again. And I'm going to collect this one, collect my calculator. What else do I need? What else? Maybe this one. All right, just again. Okay, this, and this. Sure. Okay. All right, so I want us, can you see this worksheet now? Hello, can you see this worksheet?
Yes.
Okay,
Yes,
good.
ma'am.
Thank you so much for letting me know you're not seeing it. Okay, so in this question, I just listed all the givens. So I am given that the status quo is 100. I am given indirectly that is a two-tailed test, see? I am given the sample size is 15, so it's a small sample. And I'm given that sample standard deviation is 9.5, so they don't know the population standard deviation. So it's a t-hypothesis testing, and it's two-tailed. I have all the information. So even if I do the test because I have to actually do the test using the traditional method, that is, because I'm told to calculate the test statistic. Remember that the test statistic is central limit theorem t-value. So T central limit theorem is random variable x bar minus mu over, I'm going to write this formula on the test. I'll write it on the board just in case somebody forgets it. So I need to calculate the test statistic. I also need to calculate the critical value. Okay, so let's do this. Even though I know my calculator will give me this, but the most important thing I need to calculate is the critical value. And so before I calculate the critical value, it's a two-tailed test. So I must divide alpha by 2. Don't forget this, because two-tailed test is already in your test. Divide any alpha given to you by 2. So you're going to be using with 0.005 here. Don't forget this. Okay, so I am going to do inverse t 0.005. Sample size is 15, therefore degree of freedom is 14. So let's do that. So let's go ahead and do this. Inverse t, 14 degrees of freedom. Area to the left is 0.005. So let's do this. Second distribution, inverse t is number 4. Area to the left is 0.005 because it's a two-tailed test. Degree of freedom is 14. Sample size is 15. So I'm now about to calculate the critical value. So I have the critical value is plus or minus 2.98, plus or minus 2.98. So I have to draw that diagram because I need the diagram to make a decision. So I'm going to draw the diagram. So I'm going to draw the diagram right here. And, oh, that's a crooked diagram, but anyway. So negative 2.98. Negative 2.98 right here on the left. Positive 2.98 on the right. So there are two rejection regions, one on the left, one on the right. The center is the acceptance region. So if I calculate the test statistics and it falls into the center, I will accept the null. If it falls into the left rejection region, I will reject the null. Or if it falls into the right rejection region, I will reject the null. Okay, so let's do that. We already know that my calculator will calculate the test statistics for us. But we calculated the critical value because my calculator will not calculate that for us. So we are using the traditional method first. The traditional method is the test statistic. So we are doing the test now. Go to Stat, arrow to Test. T-test is number 2. So I'm going to select T-test. I select. And what is the status score? What is the mean we are testing? It's 100. What is the sample mean we are supposed to use to test that? Given to us is 105.8. What is the sample standard deviation given to us? Is 9.5. 9.5. What is the sample size? It is 15 in this question. What kind of test am I doing? Two-tailed. So I like to draw. So I'm going to draw. When I see my diagram, it will give me the p-value, and it will also give me the test statistic. All right, so I'm going to draw. So I kind of see that the p-value is 0.033. Another way of saying is 3.3%. 3.3% is greater than 1%, though. Therefore, p-value is greater than alpha. I will accept the null with p-value. I will accept the null with p-value. Okay, the test statistic from my calculator is 2.36. So 2.36 is on the right-hand side here, 2.36. I'm going to look at it again. So it is 2.36 inside the acceptance region. Therefore, the test statistics also accepted the null hypothesis. But there is another test I can use because it's a two-tailed test. So let me quickly do confidence interval. So confidence interval is what I'm doing right now. Oh, by the way, because p-value has accepted the null, the test statistics accepted the null, confidence interval better accept the null too. So this is our lower bound. So we don't know our lower bound now. It is somewhere here, lower bound, upper bound. The point estimate is X bar, and the X bar is 105.8. So we already know that our upper bound has to be greater than 105.8, and our lower bound has to be lower than 105.8. So we pull our calculator up and do T interval. We're going to do T interval with the information we already have. It is already there. T interval is number 8. And then, okay, so the information here is still right. So X bar, the sample standard deviation, the sample size, the confidence level is 99%. I hope you agree. Because alpha is 1%, the confidence level is 99%, 0.99. Then I calculate. Oh, we have only 3 minutes. Okay, so the interval is from 98 to 113. So I'm just going to write 98.45, actually 0.5. 98.5, and the right is 113.1. Well, guess what? The confidence interval contains the status quo. We accept the null. Confidence interval also accepted the null. Therefore, I'm 99% confident that the mean of the population lies between 98.5 and 113.5. Any question? We're done with this review. Any question? Any question? So I'm going to stop sharing. Our test will be in class on Thursday, in 2 days. Any question? We have just maybe 2 minutes to go. All right. I hope to see you on Thursday in class to write a pen and paper test. You have a great day.
Thank you.
You're welcome.
Thank you.
You're welcome.
Thank you.
You're welcome.
Have a good day.
You're good. Have a good day too. Have a great day.
Yes, have a good day.
Yes, have a great day.
I have a question.
Yes, ma'am. Go ahead.
For the paper assignments, we have until Thanksgiving break to do those, right?
Yes, ma'am. Is there anyone that I need to reopen?
Yeah,
Yes.
all of them are closed right now.
Oh, okay. Okay. Thank you for reminding me. I need to go and open it. I want to keep them open until after Thanksgiving. I want to keep them open so that you can have time to do them.
Okay, thank you.
Okay. Yes, and I hope you know that all the Hawks assignments are open until after Thanksgiving too.
Yeah, I saw that. Thank you.
Okay. All right. I will open a paper assignment.
So you're gonna open the ones that were due on Sunday as well?
Yes, I will open all the paper assignments because I want everybody to do it. Everything will close after Thanksgiving. Everything,
Okay, awesome.
including, yes, ma'am.
Because I had done those and I just forgot to turn them in, but I have them done.
I think
So
I
I
just
really
saw your
appreciate
email. Yeah, okay, I will. I just saw your email before class. Sorry, I will
Yeah.
open them, okay?
Okay, thank you so much.
All right, you're welcome.
Bye.
Bye.